Greetings, I'm Dev the Developer. This lesson brings the last few lessons about collections together. We've covered arrays, lists, and dictionaries, each individually. Now we combine them. We look at foreach as the cleanest way to visit every item in a collection, and then build a pattern you'll use constantly, a list of dictionaries, and how to search through one. You already know the for loop. It's powerful, but it has three moving parts: an index variable, a condition, and an increment. When all you want to do is visit every item in a collection, that's a bit more machinery than the job really needs. Foreach handles all of that automatically. You get each item in turn, one at a time, with no indexes to manage. The syntax is the keyword for each. Then in parentheses, the type of each item and a variable name, then the collection. Both print the same thing, but for each reads more like what you're actually trying to do. For each name in the list, print it. No off by one risk, no chance of accidentally going out of bounds. One limitation worth knowing: inside a for each loop, you cannot add or remove items from the collection you are currently iterating. If you try, the runtime throws an exception. If you need to remove items while looping, collect what you want to remove first, then process the removals after the loop. For each works on dictionaries too. Each iteration gives you a key value pair, which you've seen before. You get a key and a value. You can also iterate over just the keys or just the values using ages.keys and ages.values. Both are collections you can for each over directly. Now, let's put this together in a pattern that shows up constantly before you learn about classes. A list where every item is a dictionary. Each dictionary represents one record with named fields. The list holds all the records. Think of it like a spreadsheet. The list is the rows. Each dictionary is a single row. The dictionary keys are the column names. Let's trace through that structure. People is a list of dictionary of string to string. Each item in the list is itself a dictionary. When we for each over people, each iteration gives us one dictionary. Then we use square bracket syntax to pull out the fields that we want. Is this more ceremony than a class with proper properties? Yes, it is. We'll fix that when we get to classes. But for now, this teaches you something real about how structured data can be organized from tools you already have. Searching means scanning through a list looking for items that match a condition. The pattern is always the same. For each over the list, check each item, collect or print the matches. Here's a common example: searching for people whose names contain a term. We want the search to be case-insensitive, so J.O. matches John and Jordan, but not Alex. Let's walk through this. We convert the search term to lowercase once outside of the loop, so we're not repeating the work on every iteration. Inside the loop, we build the full name as one string, convert it to lowercase, and check whether it contains a term. If it does, we print it with a number. ToLower and Contains are string methods you've already seen. We're just combining them with a loop and a condition. This pattern, some variation of iterate and check, is one that you will write over and over. Arrays, lists, and dictionaries, for each and searching. Each one is a tool with a specific job. Now, you have all of them. Go build something that uses more than one together and see how the patterns from these lessons connect. Don't just watch it. Do it.